This question is about pentan-2-ol and pent-1-ene. The alkene pent-1-ene is formed by the elimination of water from pentan-2-ol. State the reagent and condition for this reaction and then outline the mechanism. Okay, so the reagent here is concentrated sulfuric acid, but you could have concentrated phosphoric acid. Both of those are okay. And then the conditions for this is hot or temperatures between 150 to 200 degrees C. Heat is not allowed. Heat is not allowed in this. Now I need to outline the mechanism for this. So it's pent-1-ene, so the double bond is going to form this area here, which is why I've displayed the ones, the hydrogens to the left of it. Okay, I need to put my OH on here, so there's my OH, lone pair there, and then, so here's my first arrow from there to there, so that's going to be one of the marks. So it's got two hydrogens on there now, and that is positively charged. And then the next two marks, you can either do it together or you can do them one step at a time. So there is one mark for that curly arrow, and there is one mark for that curly arrow there. So if you're going to do it stepwise, the next step is to remove the water first, which will give you a positive intermediate there. You can do this in one step, which I think there's less scope for mistakes. So double bond goes here, and I've got that there like that. So where are the marks for the mechanism? So one mark for that curly arrow, one mark for this curly arrow, and one mark for that curly arrow there. Again, you can do this step here in two stages if you wish. Okay, so removing the water first, which gives you a positive charge on the carbon. Right, the boiling point of pentan-2-ol is 119 degrees C, and the boiling point of pent-1-ene is 30 degrees C. Give the name of the technique that could be used to separate these. So distillation. If you put fractional distillation, that's fine as well. Pent-1-ene can react with hydrogen bromides. The reaction of pent-1-ene with HBr forms two halogenoalkanes with the formula C5H11Br. Name and outline the mechanism that shows the formation of the major product. So the major product means that the bromine is, let's just get the highlighter on, is going to go on that carbon there. So I just need to bear that in mind when I'm doing this. So here's my HBr. So curly arrow from the middle of the carbon-carbon double bond to the hydrogen, and then a curly arrow from the middle of the hydrogen-bromine bond to the bromine. So now I'm going to put the hydrogen on there because that one is going to be my carbocation, because I've been told to make the major product. Br minus, and curly arrow from there to there, which gives me my final product. Okay, so the marks are here, here, so 1, 2, 3. That's for the correctly drawn intermediate. So if you've drawn the incorrect intermediate, if you've put the positive charge on carbon number 1, you don't get that mark, but you would get the fourth mark over here for the mechanism. I know your bromine would be in this position, but it would be an error carried forward mark. Okay, the name of this mechanism then is electrophilic addition, and there's your 5th mark for that there. Okay, so give the skeletal formula of another halogenoalkane that can be formed, but in smaller quantities. So this is going to be where the bromine is in this position over here. So let me do the carbons first. So 1, 2, 3, 4, 5, and then I need to put my bromine on carbon number 1. So beginning or the end doesn't really matter. So my bromine will go on that one there. We now need to explain why it is formed in smaller quantities. This is the reverse answer of when we talk about why the major product is formed in larger quantities. So the minor product is formed via, so formed from, formed via. Okay, absolutely crucial here because it's all about the carbocation, not the product. So the minor product is formed via the less stable carbocation. Okay, so let's just go back and classify these. So the carbocation here, so this one is a secondary carbocation. If the positive charge was on here, that will be a primary carbocation. Okay, so primary carbocation is less stable than a secondary carbocation due to the positive inductive effect. Okay, so now I need to talk about the alkyl groups. So secondary has 2 alkyls, primary has 1 alkyl.